So hello everyone and welcome to this presentation about multisensory display of self-avatars physiological states. Virtual breathing and heart beating can increase sensation of effort in VR. So I am Yann Moullec and here are my co-authors. So first, look at this man. He's seated on a couch. He's using a gamepad controller to control the movements of his avatar. So how can you enhance the connection between this user and his avatar? Well, you have several strategies to do so. You can try to have a better proprioceptive or motor correspondence between this user and his avatar, but it may be hard to do so because of the limited workspace. Then you can use the body of the avatar as a means of interacting with the environment. So for instance, you can apply vibrations on the feet of the user to represent the contact of the virtual ground on the feet of the avatar, or you can use the display of physiological parameters. So this last approach is the one we chose for this work, and we used multisensory display of physiological parameters during a passive walking simulation to enhance the connection between user and self-avatar. So you may know the notion of biofeedback as the way to measure a physiological activity and feed it back to the user in order to teach them how to change physiological activity. So for biofeedback, you have a component of measure and a component of feedback. Our system is a little bit different. You have no component of measure on the user, but instead the physiological activity is generated by the VR app and displayed to the user. So it's called phase biofeedback, and more specifically, our system generates cardiac and respiratory activity as a function of the avatar's effort while walking. So that's ground incline and walking speed. So how to display physiological parameters in VR? Well, first we're going to focus on cardiac activity and respiratory activity only, and you can use several sensory modalities to present physiological parameters in VR. You can use vision, you can use audition, and haptics. So first, our work contributes to these fields by performing a design space exploration. So we propose both visual, auditory, and haptic representations for cardiac and respiratory activity. Then we propose a new way to represent respiratory activity via haptics and thus via multiple sensory modalities, where only one was proposed in the past. It was a VR scuba diving simulator, so it was not adapted to other types of simulations. And then our work contributes to assess the impact of mixing both the display of cardiac and respiratory activity in VR. And we also contribute to studying the effects of displaying such parameters on embodiment, on effort sensation, and on user physiology. So, the first study focuses on displaying a virtual heart beating. We included 30 participants to this study, and the experimental design is the following. So you have a seated participant and a first-person perspective walking avatar. So you're going to see an example of the first-person perspective view in the next slides. So the avatar walks on a straight path with 3 levels of slope, which get steeper and steeper to have the physiological activity evolve during a simulation. And it's a within subject study of 5 conditions where we compare visual only, auditory only, haptic only, multisensory, and a control condition. We measure embodiment, walking sensation, and effort sensation. So, we present the visual cues for visual heart beating using an HMD, and the same goes for the audio cues. And the haptic cues are presented with a wristband, so it's a actuator, a vibrating actuator placed on the wrist. And here is a view of the first person perspective of the avatar. So you can see the visual representation in gray in peripheral vision, and you can hear the audio for the cardiac activity. And the rhythm which is played on the wrists with the actuator is the same as the visual and audio that you hear. So you have two subbeats. Okay, so the results of this study are the following. We have an effect on a significant effect on effort sensation. So the multisensory condition performs better than the control condition. And we have a majority of 40% of participants which prefer the multisensory condition. So then on to study 2, where we included 20 participants. So this is almost the same study as for study 1, except that it concerns respiratory activity, and that we collected an additional data which is breathing activity, user breathing activity. So first let me introduce you to the compression belt. So the compression belt is a haptic device made to represent breathing activity in VR. So as you can see on this image, there is a motor placed in the user's back, and on this motor are attached the two ends of an elastic band which wraps around the user's waist. And so when the motor spins, the band tightens around the user's waist and deliver a pressure stimulation on the waist. And when it unwraps, well, the pressure stimulation disappears. So here you can see it in action. So during inspiration, the band wraps, and during expiration, the band unwraps. And so now here is a view of the first-person perspective for the user. So now the haptic stimulation is delivered with the compression belt. So here you can see the first level slope. So the visual representation is a cloud of vapor which appears at expiration in front of the avatar's mouth. The audio representation, as you can hear, is a breathing sound. And the haptic representation, maybe you can't see it very well in this image, but it is applied to the user's waist. So the results of this study are the following. We had a significant effect on two subcomponents of embodiment. So as you can see here, we have an effect on appearance. So multisensory condition induces more appearance response than the control condition. The same goes for the subcomponent called response. So the multisensory condition has a higher score of response than the control condition. And we have a similar effect on effort sensation than the first study, where the multisensory condition performs better than the control condition. And finally, breathing offset. So here a low score means a high synchronization between user breathing and avatar breathing. So here you can see that the multisensory condition induces much synchronization with avatar breathing, and you can see an ordering effect where the visual doesn't induce any synchronization and a haptic condition seems to induce the most synchronization. Now on to the last study where we included 18 participants. So the experimental design and the collected data were the same as for study 1. And for this study we compared 3 conditions. So the multisensory display of cardiac activity, the multisensory display of respiratory activity, and a combination of both. So here you can see a video of both multisensory display of heart beating and breathing combined. So now onto the results. We had a significant effect on effort sensation. So the combination of both cardiac and respiratory activity were induce significantly more effort sensation than cardiac activity. And the rankings for effort sensation and preference show that combining both physiological parameters was preferred and induced more effort sensation than displaying only one at a time. So to summarize our results, we can say that displaying avatar physiological parameters can indeed enhance user-avatar connection. We advise for using multisensory displays because they seem more compelling than using unisensory displays. Our studies show that they can induce effort sensation and influence the sense of embodiment. And our third study showed that breathing display seemed more compelling than cardiac display. In the future, we would like to investigate bisensory modalities because our visual displays did not differ significantly from the control conditions in our first two studies. And we would also like to investigate the effects of customizing the physiological response of the avatar to fit the users more closely. So to conclude, our work can be applied to other applicative contexts, for instance video games, exergames, and VR rehabilitation therapy, all the fields where you want to have a better connection between user and avatar. So I thank you for your attention, and if you have any questions, you may ask them now.